Okay, mic is on. Right, so can you see the question paper that's showing?
Yes.
Alright, okay, cool. So we'll do that, and then we'll also keep referring to the learning guide so that whatever it is we need to answer, we can always think of like where do we find it in our textbook, in our learning guide, and what the underlying concept is. All right, so we're gonna do exam question for functions. All right, so our problem that we're given, we have a axis system, and it's marked out like that. Okay, so we've got a parabola that passes this point here. Ooh, maybe not there, but it passes through the point 1 0, and then again somewhere up there, and then the parabola curves like that, and then somewhere at the point 4 or -4 is to 5. So this is not drawn to scale, so there could be errors. So at the point -4 is to 5, and somewhere there we've got a straight line. Right. And we're told that where the straight line and the parabola intersect is point D, and also at point A. And we're given that A is the point -4 is to 5. D we don't know, it's just XY. F is 1 0. C we're not given, so I'll just call it XCYC. The other one is XDYG. B is the turning point, so we don't know what the turning point is, so it's XB, YB. That's C. Yeah, and that's everything. So the straight line is G of X, which is -2x minus 3, and the parabola is f of x, which is a into x minus p all squared plus q. Right, so we need to first find the coordinates of C. How do you think we can go about it? The coordinates of C, we know that the x value there is 0, so that we can easily determine. And I'm also willing to bet that the coordinates of C, the y value is what's this? The y value is +5, and it's,
Sorry?
I'm saying the y value for the coordinates of C are +5, and the x value is 0, and that is because question 7. Okay, so in our parabola, on our axis like that, right? 1, 2, 3, 4, 5. Sorry, have you got access to the Jamboard?
Yes, I'm on page 2 of the Jamboard.
Okay, cool, great. -1, -2, -3, -4, -5, So what we do know is that okay, at the point 1 0 we have an x-intercept for our parabola. We don't know what E is. Maybe let me erase these. Or let me rather erase everything. Clear everything. Okay, so we don't know exactly where our graph cuts the y-axis, right? But we do know that if we have a function that's parabolic like this, a into x minus p all squared plus q, right? Our y-axis, which is q, we normally find by substituting where x is 0. And where x is 0, that's where we get the y-intercept. So the first thing we're going to do is to look at that, right? So we are going to say for the coordinates of xc, yc, we have to look at where x is 0, because where x is 0, we will get this coordinate, right? It's at x equals 0. So then we're gonna go and substitute what's this? X is 0 into, or maybe not. I'm just trying to find what other point would be so obvious that that point is 0 and 5. Okay. Y equals
Probably the straight line.
We could try that. We've got the values of x and y at point A, so that could give us 5 equals a into -4 minus p squared. But okay, that's just gonna take us way the other way around. With this, okay, so you're saying with the straight line, right?
Yeah.
So with the straight line, okay, but this one mark shouldn't be more than a minute for that mark. Okay, points E, F, and C are intercepts with the coordinate axes. A is -4, 5. Oh, okay, cool. Here's a hint. So you see the point A, right? This one here. Right. It is the reflection of C across the axis of symmetry of F. So F is our parabola, and it has an axis of symmetry. Now the point A is -4, 5. So if it's symmetrical, only the x value changes, but the y value is the same. So this must be some value paired with 5. And now we know that at C, so if A and C are reflections of each other, then the y coordinate of C would be 5. But then the x coordinate of C would be 0, because on the y-axis, on the y-axis, x equals 0. So then the coordinates of C just become 0 for x and 5 for y. And that is why that is a 1-mark question. And just by reading the question clearly and understanding it, and also looking at the graph and how many marks were allocated, shouldn't be more than a minute to answer that. And yeah, so the coordinates are 0 and 5. Now we must write down the equation of the axis of symmetry of f. Now in your learning guide, where we get that is for quadratic functions. Quadratic functions are on page 61, right? Of learning guide, page 61 of learning guide and forward. When we look for the axis of symmetry, right, what we look for is a vertical line on the parabola such that the vertical line is given by x equals minus b over 2a. Now that's the formula that we'll refer to for the axis of symmetry. Now the axis of symmetry is simply on our coordinate axis system. If we have a parabolic shape like that, we're looking for an x value, right, that cuts our parabolic shape in half, so that what we have as an image of the function is mirrored about that vertical line. And that vertical line is simply represented by the x value there. So we are looking for the x value at x equals minus b over 2a. To get the equation of the axis of symmetry of f rather, since we don't have what's this? Since we've got these 2 points, C and A and F, which are intercepts, maybe we could use those quickly to just determine or maybe not, since axis of symmetry minus b over 2a. I just want to think about it real quick. Minus b over 2a. Our equation is y equals a into x minus p squared plus q. So we don't have b. Ax squared plus bx plus c equals y. What? What happened?
No, I'm saying I'm trying to follow through with the learner guide.
Oh, okay.
Ax plus x squared plus bx plus c equals 0.
Yes, that's the equation of standard form for a quadratic function. I'm just trying to think. I'm just trying to think about this one more clearly. So, it's a 1 mark question. We shouldn't spend more than a minute on it. It should be very straightforward. If anything, easy to read off of the graph. I'm gonna go with the assumption that our graph is not to scale, so I don't want to be guessing that point B is like -2 or -3 because we're not really sure about that. It looks like a -2, but I don't want to go that route because the graph could be out like not to scale, and then when we there's another formula.
0 to -2. What does it say? Oh, there's answers.
Yeah, that's answers. I just wanna, so -4, it's -4 plus 0 over 2. Where does that equation come from? Du, du, du. Wait. There's something I'm not thinking about here. Study guide. I'm gonna look at another study guide. I wanna see something. Functions on page 10. Now that's hyperbola. Okay, there's intercepts, there's domain, it's concave down, so it's okay, in standard form, that's that, fine. In turning point form, yeah, that's what I'm looking for. Minus P. Oh, okay, cool. So, okay, the parabola is given in what we call turning point form, so that if we know the value of P and Q, we will know the value of the coordinates of the turning point. That's the important thing we must note first. Then turning point plus 1 point. So we don't have the other point. We only have 2 points. Okay, let's do this. Let's be creative. Alright, so we've got the point C is 0, 5. And we've got the other point, what is it? Is it A? Okay, A is -4, 5. If we have these 2 points, if we have these 2 points, Then we have okay, but we're not given roots. That's the thing. Okay, we've got C. Determine the equation of the parabola. We're given turning point plus 1 point. We're not given turning point, we're given the other points. We're not given 2 roots, we're given 1 root. Oh my word. What is happening with me today? X equals P. I'm seriously drawing a blank today. I have no idea what's going on. And I've been feeling very tired the whole day. But anyway. Because I don't want to just say 2, you can just think minus 4 plus 0 over 2. I need to first give you where that comes from and what that all means and stuff. You know? I hate it when I can't figure out stuff like this.
Was your Microsoft after also down today?
My Microsoft.
Yeah.
I'm not sure. I haven't. Did I try using Microsoft today?
It was down.
Yeah, actually, it was. Yeah, it was. It was. Because I was trying to join the sales class that I have, and I only joined with the last half hour, at the last half hour, because the whole time it was struggling. This was at 9, from 9:30 in the morning. Did you also have trouble with that?
Yes, we did. Yeah, at work.
Is it? Yeah, that's a schlep.
Whatever that means in terms of, but let's get back.
Yeah.
It's just random for a whole system to go down.
For the whole day. Nationally as well. Yeah, that's crazy. That is crazy. I'm thinking about something. Right. A clever-ish way to think about this whole turning point situation. So at the turning point, that's where our graph gets cut in half, so that the one half is a mirror reflection of the other half. Right. So that means
The
if
one half
is a mirror reflection of the other half.
reflection.
Yeah. So what that means is that this distance, it means the distance from, so the distance here, this space here, its distance, its length, equals the same as the length there. Right? Now, if that is the case, we know that the entire distance is 4 units long. It's 4 units long because to go from the point there where x is 0 to go to the point, so to go from there we go 0, and then we count -1, -2, -3, -4 paces to end there. And we know that halfway, that's where we get our axis. That's where we should get our turning point axis. I'm not sure if this is gonna make sense to you right now. We'll have to do a couple more examples on parabolas so that you can get an intuitive sense of where I'm going with this. So if this is 4 units from where the y-intercept is to the other point, what is it called? Point A. Then halfway between should be -4 divided by 2. Oh, okay. So in the memorandum, the answer.
If you say 4 units, is it not meaning that on the x-axis it's -2?
Yes, it's -2. So I wanted to bring you to why that is. So okay, these points here, point C and point A on our jam. Let's open up our jam.
Yeah.
Right, so you see here, point C and point A, the ones in green.
Yes.
Yeah, now those two that are in green, there's an imaginary line that keeps them equidistant. So the distance between these 2 points is equal, right? That line, we don't know exactly where it is, but we know that the points A and C, they are 4 units apart because there's 0 and there's -4. So if the 2 points are mirrored about the axis of symmetry, then the axis of symmetry must lie halfway between them.
Yeah.
The axis of symmetry must lie halfway between them. And if it's halfway between them, then we know it's the second x value plus the first x value. No, minus the first x value. Or plus it. Okay. Divide by 2. So it's going to be this spot here plus that spot here, divide by 2, and that gives us -4 plus 0 over 2, and that's -2. So the x coordinate is then the x value for the axis of symmetry is then -2. So that's why it's also 1 mark. For B, yes. So it's -2. Yeah. So it's -2. Now the next part, 7.3, we have to find the values of A, P, and Q. And our function is y equals x minus p all squared plus q. Sure. We need to first start off with all the coordinates that we have for f or y. And this here is f of x. And so we've got A is -4 to 5. We've got C, which is 0.
-4 to 5 or -4 to 0? Which was it given?
-4 to 5 is the 1.8. It's given. It's given. It's a given.
It's the reflection of C.
It's the reflection of C about the line x equals -2. Yes, and we also have F, which is 1 0. We don't know E, we don't know E, we don't know D, and B, we've only got that x equals 2 there. So that being done, we want to first find A, right? Our parabola is facing downwards, so A is less than 0. That we must keep in mind. So our A is less than 0. Now we can, I'm just trying to think how we're going to find the peak. Where x is -2, what is y? Probably okay. P is -2. Okay, so we can start here. We know that our turning point P is -2. So we've got a value for this here. And if we've got that, then we have y equals a into x minus into -2 to the power of 2 plus q. Now we can look at one of these 3 points and substitute into the equation. So let's take, for example, if we know the turning point, the turning point's value as -2, then we can turn to, let's take 5 is a into -4 plus 2 squared plus q. So we've taken the point A is -4 to 5 and substituted it into the equation there. Then what we have is -4 plus 2 is -2 squared. That gives us 4a plus q equals 5. All right. Then the second thing we can do is what happens at the point where y is 0 and x is 1. So we'll have a into 1 minus -2 all squared plus q, and then we end up having, that's 1 plus 2, 9a plus q equals 0. So in this part, we've substituted the point f is 1:0 into the equation. If we make q the subject of the formula, then q here equals -9a. And if we substitute then that q back into that equation up there, then we'll have 5 equals 4a minus 9a, and then we get 4a minus 9a is negative 5a equals 5. Therefore, a equals negative 1. So we found the value for a, it's negative 1. There we have it there. So now we found p, we found a. It's should be there. Like, and this type of problem, the questions are not exactly from how your learning guide is structured. They literally just be creative with what you know. Learning guide could help, but you're not really gonna get the answers if you think too much like learning guide. That's what the question is like. Anyway, so we're left with just Q to work out. And Q we're gonna work out by saying, so now we've got y equals negative 1 into x plus 2 all squared plus q. And again, so we've used 1, 0 and negative 4, 5. So you can use 0, 5. So where y is 5 and x is 0, we will then find q. And this is 4 times negative 1 is negative 4. So negative 4 plus q equals 5. Then if we do additive inverses, then we get 9 equals q. Just want to check. Yeah, that is the correct answer. So then the values for A is negative 1, P is negative 2, and Q equals 9. And A? Say what? Yeah. I think we should probably carry on Gadi question paper because that's the best way to be able to answer. Because this question is going to catch you off guard if what you know about parabolas is only what you have in this learning guide. Yeah. You know what I'm saying? Yeah. And this then means that our equation is f of x equals negative into x plus 2 all squared plus 9, which we can say is negative into x squared plus 2, no, plus 4x plus 4 plus 9, which is negative x squared minus 4x minus 4 plus 9 plus 5, right? And this now becomes the question they lead with into 7.4, which is to say, if f of x is negative 4 minus 4x plus 5, then we must find the x coordinate of D. So f of x is that, but at point D, at D, f of x must equal g of x. And we know that f of x is minus x squared minus 4x plus 5, whereas g of x is negative 2x minus 3. Now we're going to have to solve for these equations simultaneously. And yeah, we will have minus 2x minus 3 plus 2x plus 3, so that we get 0 on this side, equals minus x squared minus 4x plus 5 plus 2x plus 3, sorry mosquito, And then we will have this and that is 8. This and that is minus 2x. And then we just have minus x squared equals 0. Dividing throughout by -1, we get x squared plus 2x minus 8 is 0. Then we can factorize here, so that what must I multiply? So I'll have a 4 and I'll have a 2. If I multiply these two, I have x squared. What's showing on my screen? Is it the Jamboard or is it the...
Well, I've got the Jamboard open. So
Okay.
you can keep the exam paper open.
Yeah, no, it's fine. So when we factorize here, we're looking at the x's will give us x squared, but what two numbers can we multiply and add to get -8 and 2? Now I think we get 4 and 2. Those are the factors for 8. So if I have positive 4 and minus 2, I might have the answer. So let's check. X times x is x squared. X times 4 is 4x plus -2 times x. So it's going to be 4x minus 2x. And then I get plus 2x. And then I take -2 and I multiply by plus 4. And then I get, therefore, x minus 2 equals 0. Or x plus 4 equals 0. Therefore, either x equals positive 2 or x equals -4. And this second x of -4 is this one here from the coordinate set of A, which is this one here in the green on the side. -4, 5. And it's that which confirms that it is indeed that, because the x value there is -4. So now that we have that, we can then conclude that the x value for point D is -2. Positive 2 is to something else. So the x value for thingy is positive 2. Now we're told that the graph of x is reflected about the x-axis. Okay. The equation is reflected about the x-axis. What that means is what is above goes below and what is below goes above. Alright. And we have to do that for 2 marks. So if
Yeah, I'm following.
Yeah, so if our turning point was -2 is to 9, -2 is to 9, I think then our new turning point, so our old turning point is -2 is to 9. That means if we're going to just mirror our parabola, which looks like that, if we're going to mirror it, then it must look something like that. So then this point must go down there and everything else pretty much stays similar, which then means the new turning point would be -2 is to -9. And Since we're told that it's mirrored like this, then A in this case is positive, and then our equation should be f of x equals positive into x minus 2 squared minus 9. I think that's what the equation should be. Yeah, so that would be, yeah, the coordinates of the new turning point would be that. So the coordinates would be -2 is to -9. And yeah, so that's pretty much how we answer this type of question. It's a bit of a tricky type question to answer. It's not as textbooky. It's very, it tests out of the box thinking. When oh, don't tell me I extend call. Yeah. So I've extended the call. Can you still hear me?
Yes, I can.
Oh, okay. So do you have questions so far?
Oh, Jesus.
Yeah? Are there any questions so far?
That's a word.
Skis. This one is, I just want to note the question paper. Grade 12 Math, February 20. It's 2014. Paper 1. Alright, so yeah, so this is more or less how we look out for it. Long and short of it, there's a couple of tricks that we need to be aware of. Some of them include the wording. Like if you really think about it, all that was tricky here is that the reflection is about point C, or rather point C is a reflection about the axis of symmetry. There was one giveaway to get part 1 and getting number 1 and 2 of the question, and calculating A, P, and Q was simply a matter of substituting. A little bit out of the norm, I have to admit, because even I didn't think they would approach it that way, but it required some out of the box thinking. And then lastly, we had to solve simultaneously for the point of intersection at D, so that we can get the value of x at D. And if the graph was reflected about the x-axis, it's just flipped upside down. So what is facing down now faces up.